Thanks, Kristen. Nice to meet you via emails. And it's nice to be on Cape Cod. I spent many years here as a kid, but most of my adult life has been working in the Narragansett Bay watershed, which does include a little bit of Massachusetts and the Taunton River and some coastal estuaries that drain into Narragansett Bay. So I'm going to talk a little bit about some of the projects that we've been working on for about the last 15 years, restoring tidal hydrology, using some of the techniques that Hillary discussed earlier. And I also want to do a shout out to my colleague, there he is, Ben Gaspar. We started, Ben and I, you're not in this one, but he was on site this day. Ben used to work at U.S. Fish and Wildlife, and now he works with me at Save the Bay, so it's been a great collaboration. How's that for sound? Is that good? Sarah and Hillary mentioned some of the degradation that we're seeing in our marshes, and about 12 or 14 years ago, Save the Bay, we did a region-wide assessment in Narragansett Bay looking at these impacts that we were seeing after starting to use Google Earth, because Google Earth wasn't a tool that was readily available. We started noticing that similar signature that we were seeing in tidally restricted marshes that had restrictions that were larger, like a road crossing, a causeway. But then we started noticing these die-off areas and subsidence basins in marshes that we had assessed about 10 years prior, and we hadn't seen the same level of marsh degradation. So this was helpful for us to get a sense of how widespread these conditions were in our Narragansett Bay marshes, and just looking over into Buzzards Bay and into Connecticut, we were seeing similar issues throughout. Our marshes are in we have more microtidal systems, and they're even more susceptible to sea level rise and to these features on the marsh that change the way the water flows in and out of the marsh. So typical vegetation die-off or stunted vegetation that leads to more impounded water over time, and then you start to get the marsh actually sinking. And you also, in some of these marshes, we start to see these filamentous algal blooms on the marsh platform, and it's the decaying peat that is fueling the algal blooms. And I don't know if those of you can see, this is a little ball of mosquito larvae. So they also, these shallower areas as the marsh begins to degrade and the water becomes impounded on the marsh platform are ideal for mosquito breeding habitat because they are too shallow and too warm to support mummy chugs that feed on mosquito larvae. And we just saw our first mosquito larvae last week. So just quickly, some of the marsh restoration strategies that we work on is both in marsh, restoring hydrology impacted by some of these legacy agricultural features that Hillary mentioned. And then also, Ben and I are going to talk at the next session about some larger scale sediment placement or sediment augmentation projects in Rhode Island. And I'll just mention briefly at the end some of the marsh migration facilitation projects we've also been working on. So to start, as Sarah mentioned, we assess, using historical aerial imagery, doing on the ground assessments at different times of year, at different tides, looking for these agricultural features that still exist on the marsh platform and still impact hydrology. And you can see the orange lines are embankments. This is a stone wall, this is an embankment. And these shallow features in microtidal systems are very shallow. You hardly notice them, but you start to notice how you'll see just a linear, like a line of disticlus, and you realize, oh, that's just a little higher elevation. So does it actually fit with a line you can see on a 1939 aerial image? And you notice that there's a little standing water behind that feature, that shallow berm that the farmers put on the marsh to prevent those larger tide events from flooding the upper parts of the marsh. And so we identify those, we identify where we want to install runnels into these subsidence basins, as well as which of the ditches do we want to maintain, because the ditch features are there. We don't maintain every single one of them, but we use those as a drainage feature, and we tie those shallow runnels into those ditches. So this is a site in southern Rhode Island on a salt pond called Winnapaug Pond. So it has even a smaller tidal range. And you can see in blue the runnels we installed. And then this is just showing how the marsh recovered after we installed a runnel. We work with our state's mosquito abatement program and their low ground pressure excavator. And this was right when COVID hit. We were out on the marsh and installed a drainage feature, or shallow drainage feature that we refer to as a runnel. You could see the first growing season, we got some initial drainage, then we'll come in and do additional hand digging to extend that drainage feature so that we'll get additional drainage. We try to do the project in phases because often there's a lot of unconsolidated sediment and we don't want to lose that sediment from the marsh platform. If we try to dig the whole feature at once, we could lose some of that material. And we found that we can have up to 6 to 8 inches of unconsolidated sediment revegetate with Spartina alterniflora or Salicornia, the pickleweed. And here you can see just after 2 growing seasons. This is a subsidence basin that had not subsided too much, so we were able to get full vegetation recovery. As Hillary said, what do we do with this peat? For the last about 15 years, we've been able to beneficially reuse the peat that we've excavated and place it on the marsh platform. And we create these small islands of peat, larger than what Hillary described. That depends upon the site. If we're hand digging, it's basically the material you have, so they could be between 3 to 5 feet wide. Ben, when he's working with the excavator, he can move the peat to areas where we're targeting for salt marsh sparrow nesting, and he can make larger ones with the low ground pressure excavator. But again, they are larger width-wise or circumference, but not height. We're just bringing it a little higher than the marsh elevation to allow for higher marsh species to revegetate. And here you can see, here's one of the ones that Ben installed that's a little bigger. Here's some smaller ones that were placed by hand. Here's revegetation after 1 growing season of one of the ones that Ben installed. And then this is after 2 growing seasons. This was bare peat, and it had fully revegetated after 2 seasons. And then after 7 growing seasons, it just kind of becomes part of the landscape. And in this last one, you can actually see some Iva has gotten colonized on it. This was a site on the Narrow River, U.S. Fish and Wildlife property, where we worked with EPA Atlantic Ecology Division and the Estuarine Research Reserve in Narragansett Bay to do a BACI design looking at the marsh response in a control, and 2 controls and 2 impacts. And we saw a change in water table, a change in vegetation, and I didn't want to show graphs today, but I'm just showing images of the recolonization. What's interesting of this site, as Sarah mentioned, adaptive management and long-term stewardship of these sites is necessary. We monitored this site for almost 10 years, and because of staff shortages, we were not able to maintain it for about 3 years. And we saw after 3 years some of these shallow runnels that were quite narrow filling in and the water table increasing again. So maintenance is definitely necessary especially in these microtidal systems where you just don't have much, there's not much drainage. It's a very narrow tidal range, and so maintenance is key. This is a marsh that Ben and I are working on, the first phase, and these projects do come in phases. Was one of the larger projects where we installed 3 culverts to restore hydrology. These were old stone culverts, thank you, that had collapsed. So we got some funding through the Natural Resources Conservation Service, restored the tidal flow in and out. We saw the revegetation of this impounded area on the south side of our tidal restriction. And then as we were doing our monitoring, I started noticing in this section, in the black area, some additional standing water on the Marsh platform post-restoration on the unrestricted side, what I thought to be the unrestricted side. And lo and behold, there was this large agricultural embankment and forming subsidence basins. So we did a second phase of work, maintaining a small part of a ditch and then installing, that's in red, and installing a runnel by hand in yellow. And we were able to see revegetation. And this marsh has had some significant monitoring done by local scientists, ornithologists on the salt marsh sparrow nesting community. And they actually found a salt marsh sparrow nest in that former subsidence basin area. So it had revegetated enough to allow for suitable habitat for salt marsh sparrows. It wasn't necessarily on one of our peat islands, but it was in that general vicinity. This is a project we did, Ben and I have worked on with Danielle Perry and others from Mass Audubon when Danielle was with Mass Audubon, and Jean Albanese and others over at the Allens Pond Sanctuary, where we identified multiple agricultural features, lots of stone walls on this marsh and agricultural embankments impounding both saltwater and brackish water. So to your question, how do you manage Phragmites? By draining that brackish water off the marsh platform, you can at least reduce the height and vigor of Phragmites, not necessarily all of it, but you can make it the conditions not as suitable for frag. And here you can see we did hand digging in this marsh. We pretty much, most of the marsh, we did all the work by hand and took out a few sections of the stone wall, just like a 3-foot stretch. And there you can see the revegetation. And just quickly, these are the photos that Hillary shared of Doghead Marsh, where she and Megan did a hydrology restoration project, a highly tidally restricted marsh with a significant amount of water on the marsh platform. Here are the areas in dashed yellow where they did some ditch maintenance and then tied runnels into it. And here, I'm not sure which one you showed. Did you show this one? Okay, so this is an area that had better recovery, and you can actually see the runnel down here and the recovery up here, also showing that these projects you want to do in phases. And then this is a site, again, less recovery. It was in one of those areas that had more open water. So it just shows that dependent upon how long that water's been on the marsh platform, the amount of drainage you can get depends upon the age of those subsidence basins. And this is just another one that was more successful because it had less groundwater influence and more recovery. So just quickly, salt marsh migration strategies, as Hillary mentioned, we're looking at where the marsh can migrate and trying to protect those migration corridors and also change some of the activities in the migration corridor. This is, again, at the Mass Audubon site where we used the Bristol County Mosquito Control's excavator to remove a section of the stone wall. We've done dam removal for intertidal, restoring intertidal flow like Buzzards Bay Coalition has done on the Weweantic River, and that was on the Kickamuit River. Changing mowing practices, just moving the mow line inland. You can see the marsh recovery. Changing some of the land use practices within the migration corridor. This is in Tiverton, where it was a tilled field into the migration corridor. This whole area is the area where the marsh wants to migrate, and there was a cobble berm along the edge of the field. And we were able to work with the state who owned this land and converted it from agriculture to we planted it with native warm season grasses. So a much more suitable habitat for the salt marsh to migrate inland over time. And we removed that cobble berm. And then I won't go into this project, but land protection is a key component, looking at where the marsh can migrate and using tools like NRCS's Wetland Reserve Easement Program to protect these low-lying uplands. A key thing about NRCS's the WRE program, it can protect up to one-to-one wetlands to uplands. So if you have low-lying uplands adjacent to a salt marsh that are suitable for marsh migration, that is a great tool for you all to use. So thank you.